So in class today, I showed you all a couple of polynomial functions that I just made up off the top of my head. I showed you the graphs of them. And just from those graphs, I was able to immediately say what the degree of that polynomial function could be. And the reason I was able to tell you all what the degree would be was because of this idea of multiple zeros. And when a polynomial has multiple zeros at a certain location, depending on the multiplicity of that zero, that indicates how the function is going to behave at that point. So that probably sounded kind of complicated, but let me give you some examples of what that means. When we have something like a multiple zero, that simply means that if we take our polynomial in standard form and we factor it, we could end up with something like this. Let's say we get x squared times x plus 1 times x minus 2. So we've taken our polynomial in standard form, and let's just go ahead and say that it's in factored form now. And we've got these three factors. The multiplicity of each factor is pretty much the same idea as the degree. The multiplicity of each factor is just the exponent. So for our factor of x, it has an exponent of 2, meaning it has a multiplicity of 2. This factor x plus 1, its exponent is 1, so it has a multiplicity of 1. And same for this factor x minus 2. It has a multiplicity of 1. The multiplicity of each of the factors dictates how the function is going to behave at the zero that is associated with each factor. Now that might sound a little bit crazy, but let's walk through this slowly. So we have three factors, which means we're going to have three different zeros. One zero is going to occur at x equals 0. All I did was set our first factor, x squared equals 0, and solve for x equals 0. Our second zero is going to occur at x equals negative 1. That goes along with this factor of x plus 1 here. And then our third zero is going to occur at x equals positive 2, which goes along with this factor right here. Now, by looking at the multiplicity of each of these factors, I can predict how the function is going to behave at all three of these zeros. Our first zero at x equals 0 has an even multiplicity. I'm just going to say even mult for short. And then our 0 at negative 1 has an odd multiplicity. And our 0 at positive 2 also has an odd multiplicity. And just like we spoke today, saying that the degree of a polynomial sort of dictates its end-run behavior, the multiplicity, whether it is even or odd, dictates how the function is going to behave just at that very small window right around the zero of the function. So let's take a look. If we have x equals 0, and that's going to have an even multiplicity, what that means is that the function is going to sort of bounce off the axis at that point. So let me go to the next slide and I'll show you what I mean. We said that this 0 was x equals 0. Maybe here's our graph. And so if the multiplicity is even, right here, and like I just said, that means our function is going to bounce off the x-axis at 0. So either it could look a bit like this. See how it bounces? It just touches the x-axis and then turns right back around. It could either look like that, or it could look like that. So it's going to be above or below the x-axis, and it's just going to touch it but not cross it. Although technically my graph is crossing it. Technical difficulties. There we go. That's a little bit easier. Now for our other two zeros, they both had odd multiplicities. So one was at negative 1, and the other one was at positive 2. Those were both odd. In this case, because those two multiplicities are odd, that means that our function is actually going to cross the x-axis at those two zeros. So it's either going to look like that. It's going to cross it at x equals -1 that way, or it could start up and then go down like that, or at +2 it's also going to cross either like that or like that. So an easy way, or at least how I remember it, is that if it's an even multiplicity, it's a bounce. And if it's an odd multiplicity, it's a cross, because it crosses the x-axis. Now you might be wondering, all right, well, all we've done right here is talk about what the graph could look like in a very narrow part of the overall graph, only right around those zeros. What is the overall graph going to look like? And this is actually something that we can figure out relatively easily. I've given you the function in factored form right now. And we don't need to worry about writing the whole thing out in standard form. That would take a couple minutes. The fastest thing to do to get the information we need, we just need to figure out what the overall degree of our polynomial is. And the way we're going to do that is just look at what's going to happen when we multiply all these x's together. We've got x squared. Then we're going to have to multiply it by this x and by this x. So that's going to give us an overall leading coefficient of x squared. The coefficient, or the leading coefficient, excuse me, the leading term is x squared. The leading coefficient is just a +1 because there are no coefficients on the x's. Oh, not x squared. I'm having all sorts of issues. The leading term, pardon me, will be x to the 4th with a leading coefficient of 1. So now, just like we talked about today, because 4 is even and a is positive, we know that the overall shape of our function is going to look like this. We know that the end behavior is going to be up and up. So let's take a look at how we could graph this function just from what we know right now. Our function is x squared times x plus 1 times x minus 2. We just said that the overall degree is going to be even, which means our end behavior will be up and up. We also earlier said that we know that we've got 3 zeros. We've got a 0 at 0, which is right here at the origin. We've got a 0 at -1, which I'll draw right here. And we've got another 0 at +2, which I'll draw right there. So I'm going to go ahead and sketch those points in. So we've got the 0 at 0, the 0 at -1, and the 0 at +2. We also said that we know what the overall shape of our function is going to be. The end behavior is going to be up and up. So that means over here to the left, it needs to be pointing up, and over here to the right, it needs to be pointing up. We also said that we know something based on the multiplicities of our zeros. We said that for -1 and 2, it had an odd multiplicity, which means at those points, our graph has to cross. So it's going to cross here and here. And at x equals 0, that was an even multiplicity, which means our graph has to bounce. So that gives us enough information to be able to sketch in what is a reasonably good rendition of our function. That looks a little bit better.